The application of Gauss theorem, that is electric field due to infinite plane sheet. This is the plane sheet having some charge. So we have to obtain the electric field due to this plane sheet at this point. So the electric field is due to the both surface of this plane sheet. So we will consider that the electric field is twice the electric field from one part or to the other part. So let's see. Phi is equal to actually surface integration of E dot dA plus surface integration of E dot dA. E dot dA for first surface and E dot dA for the surface which is behind it. Net. Then the net electric flux phi will be equal to 2EA, because phi we have discussed that integration of E dA, that is equal to EA. So phi will be equal to 2EA. Now this phi is equal to 2EA we have obtained from the Gauss theorem. We know very well phi is equal to Q upon epsilon naught. So what is actually in this we will see. We will see this sigma. What is sigma? That is called surface charge density. What is surface charge density? That is charge upon area. So phi is equal to Q upon A. So Q is equal to phi A. Q is equal to phi A. So instead of Q we will put phi A. So sigma A, sorry. So Q is equal to sigma A. So phi will be equal to sigma A upon epsilon naught. Phi A is equal to sigma A upon epsilon naught. Now we will put the value of phi E, that is 2EA. So 2EA is equal to phi A upon sigma. So E is equal to sigma upon 2 epsilon naught. We have seen that due to the infinite charge sheet, electric field does not depend on distance r. It is independent because the formula does not contain r. To learn this formula, E is equal to sigma upon 2 epsilon naught. Let's see the easy way of this proving. Large sheet of charge. Sigma, that is surface charge density, that is equal to charge upon area. And from the Gauss theorem, phi is equal to Q upon epsilon naught. Q will be equal to sigma into area. Sigma into area. Surface charge density into area. If you put the value of Q from here, then phi is equal to sigma A upon epsilon naught. But we know very well phi is equal to 2EA. We have discussed. So 2EA is equal to sigma A upon epsilon naught. So E will be equal to sigma upon 2 epsilon naught. A and A will cancel out. So this is the final proof. This is the smallest way to understand the electric field intensity due to a infinite length of charge sheet. That is a long way. Let's see in a short the three application due to the point charge, the electric field due to the point charge, due to the line, due to the infinite line of charge, and due to infinite length of charge sheet. For this, the electric field phi is equal to 4 pi r square E. R is the radius. Due to the line charge, that is E is equal to lambda upon 2 pi epsilon naught r. Due to the charge sheet, that is sigma upon 2 epsilon naught. This and this you have to learn. Now see, the electric field due to the two plane sheets having different charge and different charge density. Let the first sheet contains the charge density sigma 1 and this contains the charge density sigma 2. Now the electric field due to this, that will be equal to sigma 1 upon 2 epsilon naught, and due to this that will be sigma upon 2 sigma 2 upon 2 epsilon naught. So there are 3 points, P, P dash and P dash. We have to find out the net electric field due to these two charge sheets. So consider E is equal to, electric field is a vector quantity, so we have to consider according to direction of electric field. E is equal to E1 plus E2, that is sigma 1 upon 2 epsilon naught plus sigma 2 upon 2 epsilon naught. So 1 upon 2 epsilon naught you may take as a common. So general formula will be sigma 1 plus sigma 2 away from the both sheet. Mean whether here or here, the net electric field will have the general formula this. But if you are considering between the plates anywhere, then E is equal to E1 minus E2 or E2 minus E1, whichever is bigger you have to put. So sigma upon 2 epsilon naught minus sigma 2 upon 2 epsilon naught, 1 upon 2 epsilon naught take out as a common, so it will become 1 upon 2 epsilon naught bracket sigma 1 minus sigma 2. This is the general equation of electric field intensity at the point lying between the two charge sheets. Let's see if the both charge sheet having equal charge density. then what would happen? Suppose that it is positive, it is negative, then it is means positive plate will actually apply electric field away from it and negative will apply electric field towards it. Now, so here the electric field, the general formula will be E is equal to E1 minus E2, that is 1 upon 2 epsilon naught sigma 1 minus sigma 2 here and here, and between the plate that will become E is equal to E1 plus E2 1 upon 2 epsilon naught sigma 1 plus sigma 2. Means electric field intensity due to the charge sheet you have to consider according to the direction of electric field. But suppose that if both the charge sheet having equal charge density, then the general formula for these two cases will become 0. But here the electric field will become sigma upon epsilon. Now see the last thing, the graph, electric field versus the distance. Suppose that we have a sphere having some charge. So a conducting sphere having the attribute that the charge lie over the surface. So inside the surface no charge lie. So the electric field inside the surface will be 0. Means from center to the below to the surface the electric field will be 0. At the surface the electric field will be sigma upon epsilon naught r square upon r square, or you may write 1 upon 4 pi epsilon naught q upon r square. This is the general formula. As we move away from the center or away from the surface, then the distance increases, so electric field falls. As the r increases, the electric field